Okay, so now to find the third term, I plug in 3 right here, and then just follow the pattern. If you need to, just do the 3 minus 2, which is 1, 3 minus 1, which is 2. So that means this. To get A3, I need A1 and A2, which I can find on the previous problems. All right, A1, 6, and then A2 we just found is 1. So substitute those in. So 6 plus a half is 6.5. Okay. Here's K equals 4. 4. I need the second term and third term. Plug them in. We get 4.25. All right, and there's the last one. Okay, these take a little used to get, a few practice problems to get used to, so you'll have a chance to try these a little more in the OTI. But here's a good reference for you. Okay, last learning target here. It's on the next page. Last type of example. Write an expression for the apparent nth term of the sequence. Assume n begins with 1. I think it's a good idea to jot this in here somewhere. It always helps to label your rows for n and a sub n. Label your rows for n and a sub n. Okay, so they want us to write an expression for, basically come up with a formula. Like the sequence is already expanded. So it's a backwards problem to what we're doing here. They're giving us this, and we're supposed to write a formula for it. Okay, so here's what I recommend. Okay, put the n terms right underneath it, so it kind of creates almost looking like a table. So n typically usually starts at 1 with these. There are some exceptions, but let's just start with the one that starts with 1 right now. So put 1 underneath that one, put 2 underneath 7, and so on. Put 3, put 4, put 5. Okay, and this, remember, is the output. So wherever you want to fit a sub n in, but this are my a sub n problems, or I'm sorry, terms right there. And then you start playing with some things. What pattern might you see? Anybody see it yet? Yep. Multiply by 3 plus 1. Good job. So they're multiplying, and some students like to even create another column. So for example, if you wanted to check the triple numbers, which some of you already saw, what if I made another row and just tripled these? So this is 3, this is 6, this is 9, this is 12, and then this is 15. And then you can really see the relationship. What's going on from 15 to 16? Just 1. 12 to 13, 9 to 10. So that's exactly what's going on. That's how we go from n to a sub n. We'd say, here we go, a sub n is equal to, we're tripling n, so 3n, and then what? Plus 1. There we go. There's the formula. So you're trying to come up with a formula how you go from n to a sub n. But the directions, they don't kind of walk you through what's going on. They just say, write an expression for a sub n that can be confusing. That's what you do. Okay? Now, 10 has alternating signs, so I'll give you a moment to look at that, see if you can come up with it. Maybe even create a thing with n, play with maybe another row, and then maybe look back to the first page. How did they come up with a way to change signs? Go ahead. Here's the pattern we saw on the first page. -1 to the n power creates this alternating signs. Okay. All right, so that's one thing we could do right away. You could actually put the negative, well, hold on, I'll get there in a minute. So we have -1 to the n is going to alternate the signs. Here, these are powers of 2. These don't usually get too tough because I get it. Sometimes you got to have a good mathematical mind to just see some of these patterns because there's not a clear, concrete way to go. Sometimes you just got to investigate. So, but these are powers of 2. 2 to the 5th is 32. 2 to the 4th is 16. 2 to the 3rd is 8. Okay? And so on. It works. So we'd say 2 to the n power is working, but the problem was it was negative, right? But so always check your answer, see if it works. Is -1 to the 5th power negative? Sure it is. Okay, so for example, here's the check, right? A sub 5 equals -1 to the 5th times 2 to the 5th power. Does that work out? Yes. 32 times -1. Check. And then when I go to the 4th power, it becomes positive. Okay, you could get by with putting the negative right in here. That would actually work, but I'd probably do it this way because that's what the authors would probably do too. Okay. All right, let's look at one of these fraction ones to wrap it up. 11 and 12 are very similar, but 12 has the alternating going on. So whatever pattern you find for the numbers, you just tack on the -1 to the n power. Okay, so let's go to 11. Remember, this is a sub n. Put your row of n's underneath it. 1, 2, second term, third term, fourth term, fifth term. Okay, and it keeps going. All right, sometimes when you have the fraction ones, just do one at a time. Don't look at the whole thing. So for example, how can I go from these n values to the numerator? Just focus on that. Anybody see a pattern? I go from 5 to 9, from 4 to 7, from 3 to 5. So the pattern here is to double it and subtract 1. Sometimes it's hard to see, but that's why you just got to investigate things. Like maybe even create another row of 2n. What does 2n look like? Well, 2n would be 2, 4, we'd have a 6 here, we'd have an 8, we'd have a 10. And then now really look what's going on. All right, I'm just taking 1 away. That's actually going to help with the denominator too, but I'm not going to get too far ahead of myself. So here we go. A sub n equals. How do I get the numerators from n? You double them and subtract 1. So 2n minus 1. Okay. Now look at the bottom and compare it to 2n. 2 to 3, 4 to 5. Those are just one more. Okay. That's it. Some of them get tough. I get it. You might get a little frustrated with it, but you know what? In this class, sometimes problems will be easy, sometimes they'll be tough. It's just the way pre-calc is. I didn't make it that way. It's the way it was before I ever touched it. All right, so that's it for today. We'll finish up the last 2 learning targets.